Good day, everybody, and welcome to ArcGIS Data Interoperability in Action. Connect, transform, and automate. My name is Bruce Harold, and I'm the product manager for the Data Interoperability extension. I'm located at Esri's campus in Redlands, California. Now, you may already be aware of the extension's ability to do things like translate between hundreds of formats and to transform the data on the way during its transformation in terms of geometry and, of course, attribute schema. These are the two classic ETL or extract, transform, and load use cases for the extension. You may be less aware of the abilities of the extension to do things like validate business rules, both within and between features and feature sets, and integrate with storage technologies, not just relational databases, but NoSQL databases, web as a file system, web protocols, such as HTTP and FTP and WebSockets and so forth, how you can leverage web APIs, based on, say, REST and SOAP standards, and how you can use data in one of the semantic web formats such as JSON and XML. Also, you may not be aware of the extension's ability to help you with your sharing workflows, upload and download to, say, web as a file system like Amazon S3, Dropbox, Box.com, OneDrive, and so forth, how to use web tools as geoprocessing services, and how to leverage various messaging capabilities such as email. So a feature, and some would say a great benefit of the extension, is that you can do all this kind of development work without any coding. The extension delivers a visual programming environment application called Workbench, so you don't need to code. Having said that though, if you have some Python skills, you can use them inside the extension. I personally do this from time to time to condense my workflows, with the possible expense of making things harder to maintain for somebody who isn't me. We're going to be very demo heavy today. Here's my laundry list of demos that we have time for. I will, of course, in the first two there, cover quick conversion, importing of data, and one use case for some schema manipulation, or ETL, I call it here. And then I'm going to move on to how to use data that's available at web URLs. I'm going to introduce the concept of a web app connection. We're going to have a look at custom formats. That's ones you make for yourself if the hundreds that are supplied are not enough. We're going to take a look at how to integrate with Microsoft Office. And lastly, we'll look at how a published spatial ETL tool works as a web service rather than anything deployed on your desktop. So without further ado, we'll move straight to software demonstration. So my first scenario is I've gone to the US Geological Survey's map store on the web here, and I've looked up a map I'm interested in, and I can take a peek at the map on their site. Notice it's still up on the web somewhere, and I see a beautiful source of contours, imagery, road and hydrography layers and so forth available to me as a PDF file. But where I want it is inside my GIS. How do I get there? Well, the first step of all is make sure you have Data Interop extension enabled and installed. So before we do any software work, we'll go backstage here. We'll look at our licensing tab. Yes, we have Data Interop licensed, but it is a separate install. Have we got it installed? We can check if we got it installed by looking at System Tools. Are these tools available? Quick Import and Quick Export. Yes, they are. So I think we're good. We can proceed. Now, I've previously processed the data, but I'm going to show you the workflow regardless because I want to make some important points. We're just using Quick Import, out of the box tool. Let that hydrate for a second. Here we go. That's a very simple tool. You get to choose a data set as an input, and there are, like I say, many hundreds to choose from. I'm going to filter the ones I'm interested in to just be PDF. And it says Adobe Geospatial PDF. That's what we're looking for. And we're going to pick the file that we want to work with. It's one I downloaded from USGS's site. So far, so good. Always in this situation, you're presented with some parameters that you can choose, modify. I'm just going to go with the defaults and say, yes, I want the spatial data. Say OK. Let everything else default. And then the tool will inspect the data for validity, and offer me a default output file geodatabase, which I will accept, and I will run the tool. I'm going to open the details pane here for the tool. Not that we're going to get a lot out of watching the log, other than what you will see from time to time is warnings and errors go by when you're using the quick import or quick export tool. Now you don't have to worry about them. The whole reason I want to show you this, the details pane here, is that you are going to see warnings and errors, but they don't matter. The system is very tolerant here, so it's always going to give you a nice default experience. It'll do the best it can and get the data in for you without you having to worry about anything that might be wrong with the data or need ordinarily to be handled with some kind of special treatment. So it's a non-trivial file. There's some thousands of features in size. It did write all the features, even though in geoprocessing terms the tool errored. If I go to my catalog pane here and I refresh my folder, it did make the geodatabase it said it would, and there's my data. And I've added it to my map here. So I can zoom in to an area here, and all is well. But something, in fact, isn't perfect with the data. If I looked at the ortho images and the shaded relief data that came through, I would find out that they are empty polygons. They're not the nice raster data layers that are available in the PDF. So it was good, but not great. Let's see if we can do better. And we can, of course, with the extension. So in Quick Tools here, I've made a Spatial ETL tool inside a normal project toolbox. And we're going to edit it to see what it does. If you haven't opened Workbench before, I'll demystify a few things for you. These large rectangles are just things called bookmarks that you can organize a workspace with. The blue things which I've put inside the larger rectangles are called transformers, and the blue things do things, is what I like to say. Of course, they transform data. In my case here, they're simply writing data to disk and picking up the file paths. And the brown things own things. They own the reading of the data and they own the writing of the data. So really the whole thing is just a pass through, and I'm going to run it here so you see it work. It's going to haul the imagery out of the PDF file and write it into file geodatabase as a mosaic data set. Now you see some numbers appearing on the connectors there. Those are the numbers of features. So it looks like the imagery is tiled inside the PDF file, and we get 70 features in per imagery layer or raster layer and 70 out. Remember, all it's doing is just hauling the data out and writing it to disk and writing a reference in the geodatabase. So in a few seconds here, I've translated my data from geospatial PDF to file system, and here's where it put it. All the shaded relief and ortho files are there, and if I go back to Pro and refresh my project folder, Scratch 2 is there with the data in it, and I've made imagery layers inside a new file geodatabase there. So that helped close the loop very simply in a little gap that there is there in the quick tool of not handling raster data. So it's our first quick look at simple, powerful data conversion. And the message here from that demo or pair of demos is format conversion is easy. Okay, let's move on to my next scenario, simple, powerful ETL. Now, go back to a browser here. The state of New York offers in its GIS data clearinghouse the ability to download address point data. And here it's split out by county, and I can also download the whole state. If I click on one of these links here, I get the option to download either a zipped geodatabase or a zipped shapefile for each of those counties. This is great. Now, a very common use case for this kind of data is to power a geocoding locator in ArcGIS. How's that going to work for us? Well, here's the data in Pro, and I've downloaded the county of Albany in New York. We'll go downtown in Albany, and I want to inspect, well, first of all, we're going to look at the data. Excuse me. I'm going to look at the fields in the Albany data as downloaded. And being data professionals, this is the kind of thing we'll do before we start designing a workflow. I can see the house number there is called address number. It's a long integer. Okay. There's some prefix and suffix address number components which are available as text. So when we build a locator, we want all that information to be in one field. So there's a little bit of a hurdle to get around because one of them is a long integer and two of them are text. There's similar issues available or visible in things like the street names. State of New York has a data model where they split out some components into a pre-modifier and a post-modifier for the street name. Sometimes those parts go into the prefix direction, sometimes into the street name, sometimes into the post direction, and so forth. So there's some issues there we need to handle before the schema is in the right shape for creating a geocoding locator. Now, a person who does not have the extension might simply open up feature class to feature class, geoprocessing tool, choose the Albany data, give it a new name, and get to work with the field map control, trying to do things like join, add a new source, and add a prefix number to that, say, for example. We didn't look at some values, we'll do that shortly. Add that guy in there, add selected, and I want to be able to concatenate that. Oh, I can't. I can't use the join unless I go over here and make it a text output field, at which time I can join, and then the join delimiter might be nothing if I want to concatenate it with no space, or it might be a space character. But when I want to look at the data, when I do look at the data, here's some of the features here which have a fractional house number. I'm going to want to concatenate that half to address number with a space between them. If I look at other cases here, where there's a modifier which is a suffix address number here, I'm going to want to concatenate that A to that 558 without a space, because that's how people use those numbers. There are other issues here. This is a situation where there's a modifier available in the street name. In this case, it is Lower Sage Hill Lane. Sometimes we have things like upper. Sometimes after the name of the word we have things like extension or bypass or some other keyword like that. It's great that the state of New York has that in its data model, but we need to handle those cases flexibly when we're merging those values into the components that we need in our geoprocessing environment. And the field map control in feature class to feature class does not have that case handling capability. So it's data interoperability extension to the rescue. And I have made a Spatial ETL tool up for the purpose. Now the first tool we saw was basically a pass-through of the data from a reader to a writer. Very little happening in between. We're stepping up a little bit here in that there's more going on. So in this workspace here, I don't have a reader. The reason I've done that is I'll start to run the tool here. I've made the workspace so that the user can choose the name of a county as the county to download from the website. Having chosen the county name, there's a little look up here to the URL that's necessary to get hold of the zip file. Now that was simply harvested or scraped from the website. It wasn't very hard to build a tool. Having got hold of the URL, I can use HTTP protocol to go and get the zip file from up there. I can read the zip file directly with this feature reader, and at that point I have individual address point records or features, and I can manipulate their schema. And I do that simply and powerfully with this transformer here called an attribute manager, which gives me a configurable grid where I can choose the name of an input attribute, what it's going to be called when it's output, what I do with the value. So I might delete it, I might rename it, but more powerfully I might adjust its value based on some conditions. So for a street name here, I set some conditions and some value outputs here, all without coding. This is, like I say, a configuration step. Once you've got it done once, you can reuse many. Okay, so the data at the back end is refreshed every 2 weeks. Once I've built my tool, I'm good to go. So some of these things get quite big configurations, all right, but you're only doing them once. Okay, so at this point, I can run this tool and it will generate the data that I want on demand, which is good but not great. So how can I make it great? Well, here, and the message here is that to improve interaction between Spatial ETL tools and ArcGIS Pro, you use Model Builder. I've made a model up here. Its first process is the Spatial ETL tool. There's a Python snippet that hauls out the name of the file that's created in the file geodatabase, the name of the county. Then I make a feature layer from it, and I symbolize the feature layer. So this is a much better experience for the user. And if I'm going to share this tool, my colleagues and co-workers will be appreciative of the work. So let's run the tool here. We'll go get Hamilton County. Again, I'll bring up the details pane here so you can see what's going on. I chose Hamilton County because it's the smallest in terms of address point count in the state of New York, a little over 7,000. So I chose my county, the tool reached out to the web, downloaded the data, did its transformations, and made the feature layer. So here's Hamilton County with the schema in the shape that I need it to make a geocoding locator. One street name attribute, one address number attribute. Pre and post directionals and types are all good, and there's some richness here in terms of subaddress data and so forth, but the point is I am good to go. So like in any good cooking show, let's really close the loop here. Let's add in this guy. Go to Suffolk County, which is hundreds of thousands of points, not just 7,000. And I did make up a locator, which I've enabled in my project here. I'm going to locate this address. And there it is, ladies and gentlemen. I now have a functional geocoding locator built from data I've downloaded from the clearinghouse that New York host for us. So there it is, end to end. A simple and powerful use case for Spatial ETL inside ArcGIS Pro. And just to reiterate, the takeaway message from this demo is that to achieve really good integration with ArcGIS Pro, use Model Builder to add behavior to the Spatial ETL tools. Okay, now let's look at some web data. You saw me download zipped file geodatabase from the web, and it all worked. So that was, a static download. That's good. Many cases, however, your data that you're interested in is going to be a service of some kind, a feed. Now, while ArcGIS Pro can natively consume WFS endpoints, sometimes it makes sense to do so more richly than the default behavior allows. Now here I'm interested in this contour data is provided as a WFS service from a national mapping agency. It's nationwide data. There are millions of features. It's not easy to handle millions of features in a performant way inside a session and get the data product out that you're looking for. In addition to the contours for this terrain here, I'm interested in some other feature services that are available that provide height points and the river beds and stream beds for that terrain. So they're kind of associated data layers. And I want to make a data product up from the contour data, the height points, and the rivers so that I get a nice map or scene. This is 3D scene that agrees with my data I can see in the scene here, the nice little volcano we're looking at. So how do we do that? Let's go here. Like I said, while Pro can consume WFS services, I want to do so powerfully. And so we're going to step up the game here again and see what else we can do with the Workbench application in that regard. So there's not a lot of stuff going on here, but a little bit more. I'm reading these things on the left here are simply the WFS endpoints. If I look at the parameters for the tool, see them here. So those WFS services are going to be read. Two of them are 3D data, but aren't as delivered. So I'm going to make them 3D by forcing the elevation attribute that comes with the data to supply the elevation coordinate on the data. And for those layers, I can write them out as going from 2D to 3D in the FileGeo database, and I'm good to go. Having got contours and height points, I can make a surface with this transformer here. I can take my 2D river data and drape it over the surface this transformer manufactures and write it out to an elevation raster dataset in the FileGeo database, and at the same time drape the rivers to make them 3D. So all is good. I'm doing a lot of powerful work here with only a handful of transformers, but wait, there's more. I've also leveraged the ability of WFS services to be called within an extent. So in the coordinate system used by the data, those four numbers there supply a bounding box within which I'm interested in operating. So rather than the millions of features accessible from the service itself, I can access only an extent for the purposes of making my data product. Now, how do I make that configurable by the user? Again, we leverage Model Builder to create interaction with the behavior we need in ArcGIS Pro. This parameter here is a feature set. Okay, so it's a dynamically supplyable or supplied polygon data set. I again provide or use some Python snippets to just get hold of the bounds values, the X, Y, minimum, maximum for that feature set, and those become the inputs that you just saw in the Spatial ETL tool, and that writes out my data. So at runtime, if I can say, let's make this happen, I'm going to go to, I made here earlier a feature set and left it in my table of contents here. That's my area of interest of extent here, the little blue thing floating up in the sky. I could use it as the input to that model. When run as a tool, I could make new polygons up at the same time. And when I run this data here, it's going to make for me a new data set, several new layers inside my output geodatabase, which it's quite big data, so I won't run it live here, but I will get hold of it here, contours, height points and rivers, and we'll add them to the map. If I let the data run, this is the output that's generated. Now it's not cached, so it's going to take a second to hydrate here, but in the extent of interest, the footprint of that blue rectangle, and I'll make it vertical here so you can see that it did work. Strictly within that blue rectangle, I now have the data product I was interested in, which is 3D data generated from 2D WFS endpoints. So that was some more powerful processing of web data, namely services. Okay, web data number 2. Again, the message, just to reiterate one more time, use Model Builder to forge agreement and behavior between Pro and Spatial ETL tools as you want it. Okay, web data number 2. Here's the border area between the US and Canada. And in fact, the area of interest here is going to be Ontario, Canada. Here's a site that Ontario Travel Information stand up. It's their 511 data, so it tells you at any point in time what's going on in terms of street repairs and accidents that might affect your ability to do some routing, so for example, running a logistics operation. So this is accurate or valuable real-time data. And if I followed some links elsewhere on the site, there are places where you can download the data. In fact, here's one URL or the URL for downloading that 511 data as JSON. My browser recognizes JSON, so it gives it to me in a human readable state here. There's some attributes that we can read, like just descriptions. There's attributes that we can't really read, which are timestamps in seconds since the epoch. That's kind of hard to consume easily, isn't it? And then latitude and longitude. So it's it's wannabe spatial data and it's wannabe temporal data. So how do we make it so? Again, data interoperability to the rescue. I'm going to say I made a spatial ETL tool up, and it's pretty simple. It reads that JSON endpoint, which is that URL there. It turns latitude and longitude into coordinates. And here it's simply doing the right thing with the date time attributes and casting them from seconds since the epoch to the real deal and writing out to file geodatabase. So on the update frequency of the website itself, we can run this and get the data through as we want. But one more time, we can do an even better job by adding the Spatial ETL tool to a model and doing things like apply symbology. So if I run that tool, a model as a tool, it'll make the symbolized layer up and add it to my map. Takes a few seconds, holds the data down, and there it is appearing in my map. Let's go to downtown Toronto. So if I was running some logistics analyses here or workflows inside Pro, I can in short order obtain real-time barrier information from the authoritative site. So that's a couple of examples of downloading of feeds. One WFS and one is a JSON feed. So those integrations, again, were easy without any coding. Now we're going to take a little break from looking at maps and stuff, and we're going to look at web connections as a technology. I made an ETL tool up here. We'll have a look at it and show you what it does. Okay, so no readers or writers because we're not really doing anything with GIS data. The guy here makes an arbitrary feature, and here we've got a thing called a box connector. Before I go and demystify that, I'll show you something in the options area here. If I go to web connections as in my settings environment for Workbench application, I see I've made some connections up here. They've got funky names, but basically this one connects to Box, which is Esri's corporate web storage technology, commercial product you can obtain it to. This thing here is a connection to our enterprise GitHub environment. I made a connection to ArcGIS Online and one to Google Gmail. If I wanted to add a connection, there are a whole bunch that are configured and available to me, environments, web environments I can get hold of, and I can add to that configurable set myself through dozens more, including by downloading them from the FME Hub, this is how I made a connection to our enterprise GitHub environment. I manufactured my own OAuth2 connection to GitHub in this dialog here. So a little bit of reading of the help and some configuration, you can connect to technologies like Box, Dropbox, OneDrive, Amazon S3 and so forth. And in my case, I'm going to do an upload. I could have done a list, download, delete. Never mind the details here. I've configured this thing so it will upload something. In fact, it's going to upload a PDF file I made in Pro to my Box account. I'm throwing in here a Python snippet. We'll have one or more brief look at Python in the next demo, I think. It's not doing anything other than opening up my browser. So without further ado, we'll run the tool. And the file on disk is uploaded to Box, and my Python snippet opens my Box account, and I can see the data in preview mode. Here's the account. I'll move this tab over a little bit. Here's my Box account. I'll refresh it here, and my PDF file is now there. So quickly and easily, I've shared some data with anybody I care to make the URL from Box available to. So that was a quick look at web connections and their integration with one app, for example, namely Box.com. Okay, another time here, another thing, while we're digressing from looking at maps and stuff here, let's have a look at something back to Earth. We're looking here at a portal technology. It's actually technology called CKAN, C-K-A-N, and looking at example of some open 311 data. It's pothole reports. It happens to be for the city of Bloomington, Indiana. And this particular portal, or this one I think you can go to called Open 311, there are hundreds of these sites, and they have valuable data in. I can explore these pothole reports interactively on the site, and I'll do that now. So if I look at the potholes in Bloomington, I can see that's like spreadsheet information with quite a bit of data in it. And it's got locational information in it, addresses and coordinates. I can download the data, which I've done. And here it is in Excel. So pretty good. There's timestamps. There's managerial kind of information like who owns these problems with these potholes, and the citizens, because this is crowdsourced data, their description that they input in to the systems upheld by the city. And so it might have come in by phone call, it might have come in by a web form. I like the one where they emailed the mayor, or there was a constituent meeting. So there's all stuff's coming in from all over the place and being aggregated, and it's just there waiting to be used. Okay, how do we use it? Now, let's edit my Spatial ETL tool that does the job. Change the maps while we're thinking about it. Okay, again, a little bit of a step up in terms of complexity of the workspace that we're dealing with here, because we've got stuff going on. I will walk you through it. So looking at the parameters that I've designed this workspace to handle, this is the path to the CSV data that the CKAN portal gives us. I'm writing out to my project geodatabase. When I inspected the data, I could see that some records had Latin long. That's good. Some of them had no Latin long, but do have a street address. Some of them don't have lat long or street address, and some of them have street address but no lat long. So, it's kind of challenged. This data is challenged. So we have to design our workspace to handle those challenges. First thing I do is just make sure the dates are properly cast to what we need to store. For those cases of whether or not there's any kind of locational information, I'm using this thing here called a test filter. All it's doing is asking if things are null or not null, and there's a little bit of logic there, and basically my outputs are yes, it has an XY, or it has an address but no XY, or it doesn't have either. Based on that condition, I can say if it has XY, that's good. I take it out through a workflow that writes out to a feature class here. Or if it has an address but no XY, I can geocode the data with this tool here, this bookmark with two transformers in it. And if the geocode's successful, That's good. Take it out to the feature class. If it's not successful, take it out to this tabular data here, which is where the stuff with neither X, Y, or address goes by default. So that's okay, but also when I looked at the data on the map, I found that this being crowdsourced data, you couldn't necessarily trust it, and visitors from South Dakota and Texas and so forth had put in locations for potholes near their houses, which are not going to be of any interest to the management at Bloomington, Indiana. How do I pick apart that issue? Well, here I calculate the average X and Y values for anything with coordinates, and a stealth Python digression here. I use an industry standard formula for calculating the distance between points on the Earth's surface to generate a length between the mean XY and where the XY is for the pothole that was reported. And if it's less than 100 kilometers from the average XY, I'll trust it as being intended to be in Bloomington, Indiana. Otherwise, I throw it out and it goes back into the table here of being not located. So far so good. I can run that guy, and we'll do that now. And what it'll do is we'll see the feature counts go by. I can't remember how many features there were in the incoming spreadsheet. Anyway, it's being pulled down from the web. Looks like there's a couple of thousand. And depending on the case handling here, stuff is going through to either the located bucket or the non-located bucket and output as a feature class or as a table. So far so good. I won't cancel that. I'll go back to Pro here, and the data is in the map here. If I refresh the map, there might be some changes. It looks like Bloomington's got more craters than the moon, but in fact most of the issues are historical. They just end up being available in the source data. Okay, so I've symbolized the potholes by where they came from and information. It's quite entertaining to look at sometimes because there's some good commentary coming through from the citizens here. But anyway, the point is I have reached out yet again to some data on the web in a non-Esri technology portal environment, and I've got it into our environment without any issues. Now, my next scenario is going to be, I'm calling this map custom formats. Why am I doing that? Anytime you write out to geodatabase environments, you can export the workspace as a custom format. That will encapsulate all this processing and logic in the workspace into a file which you can reuse and share. So having done that, I'll move on to one more demo. I saved that pothole reporting out as a custom format. I'm going to look at how I can use that in another workflow, which is namely writing out a report. Here, the input parameter is the same as the previous workspace. It's a URL to the CSV data on the CCAN portal. But this time, instead of it looking like a CSV file input, it looks like a feature class and a table, which was the whole idea behind the custom format being generated for that data. Didn't have to do any extra work. I just did some saving as something, and I've got a powerful encapsulation of a CSV endpoint as a feature class and a table. I'll run this tool so we can have a look, make a couple more points. There's a green thing crept into the workflow here. That is yet another transformer. It's simply a way of grouping transformers into what's called a custom transformer. I go back here by clicking on the green thing, and I can see the data moving through. So I'll go back here. Features are coming through the workspace one by one. I'm testing here that only open cases are of interest here for my reporting purposes. And you can see that of the 2,000 or so that went through, there's only really a handful that end up being reported on. So what's the rest of the workspace doing? It's manufacturing components of a Microsoft Word document. My green transformer here, the composite transformer, it goes to ArcGIS Online to get a map chip. Here's the URL being called for the World Street Map service in ArcGIS Online. haul out an image chip, and that becomes an image component of a Word document. The description information you could see in the map here, like this, not a large north side pothole, etc. That becomes a heading, sorry, a description element here inside the Word document. There's another field there which I use to make a heading, and I put a page break in the Word document in between records. I sort the elements so they go where I want them in the document, and I write out the document. And here is the Word document. So some reports don't have a map and some do, based on whether or not they were spatial or not. So here I can give this to my field crews, or the supervisor can look at it and say, here you go fix this pothole. Here's all the details you need on it, and we'll refresh our portal information for the citizens to look at. So a couple of points here. I have leveraged an ordinary, or the ability to download ordinary data like CSV, turn it into an interpretation of the data as a custom format, and written out a product from using that custom format to a non-spatial but highly useful format, which is named in Microsoft Word. So there you go. You don't need to work with spatial data. You can work with tabular data alone and turn it into spatial data if it has that quality within it. So the last demo, folks, is from real life here in the office. We have a mining customer who has hundreds of their own users in offices around the world. And they're using a technology called MapInfo. It's a desktop GIS. And the data that they're handling includes data like what we're looking at here, which is borehole information in the state of South Australia. So there's all sorts of rich attribution in the boreholes, and they want to make that data available as geodatabase feature classes to all their pro users. But they don't all have data and drop extension, so they can't simply use quick import to do this on everybody's seat. They want to be able to do this by using a web service. How do we get there? So the first things first is a Spatial ETL tool that does what we call a dynamic translation of the MapInfo data to file geodatabase. So you can configure this workspace, and it doesn't get much simpler to read in tab data, which is the acronym for MapInfo tab, and write out file geodatabase. But in both cases, the input and output destinations are zipped. Okay, you can do that with data and drop extension. Data can be zipped. So far so good. Very simple translation. But the data isn't coming to us zipped. In fact, or the customer's data is not zipped. Here it is. This is actually downloaded from the state of South Australia's website, which is free to air. There are hundreds of these files here which we want to be able to make accessible to the end users. Got here the ability to translate them once they're zipped. So I made a couple of script tools up here that do zipping and unzipping. There's nothing that's not has no dependency on data interop. It's just normal scripting. Here again, I have made a model up which ties everything together. Here's my zip tab file parts. I pick some file names, 4 at a time. Let me see what's the we've got AAR going there. Then the script tool is referenced. I don't want to scare you with Python, but just to demystify it, there's some code in there that does the zipping. Then the zip file is created, and the Spatial ETL tool is in fact the last process, and it's doing the one little tricky thing, which is overwriting its input, which is rare but legal. Okay, so we are good. We can run that here. I'll do it locally first. So I pick in the data folder. Let's go with this one here. There are hundreds of these files, and MapInfo tab is analogous to Esri shapefile in that it's a composite format. So there are 4 components in this case to each logical tab file. I'm going to pick the Abilene Minerals one here. There are hundreds. So I've got my 4 inputs that I need. View the details. Let everything run. And so that MapInfo tab data is being zipped, converted to file geodatabase with dynamic attribute handling, and written out back to the same zip file that was sent in. So when operating locally here, I get the zip file returned to me inside as a file geodatabase. So we know that the workflow is good. How do we get it into hundreds of people's hands? The answer, of course, is to publish a web tool, and I've done so. Okay, here is that web tool. I'm going to run it, open. So now I do not need to have data and drop extension deployed locally, licensed or deployed locally. I can pick my 4 files and I say run. I'll get the details pane up so we can see the action. So the job has been submitted to the server. It's executing, and what gets returned to us, because the output is of type file, is in fact the file. It'll download to my local system. So picture hundreds of geologists around the world with their MapInfo files and a copy of Pro and access to this service. They can turn their MapInfo files into these dots on the map simply by connecting to the server and running the data. Succeeded. Here's a zip file downloaded to my machine. And I think we're done, folks. Let's get back to our last slide here. We went through the software demonstrations. Let's see if there's anything I wanted to say on that last demo there. And I guess the bullet point is that Spatial ETL can be a web service. Now, lastly, here's some resources. We have a new standards and interoperability GeoNet space. There's the link to it. You can get there easily with tags like ETL, interoperability, FME, and Workbench. Again, Data and Drop Extension is a software download in addition to regular Pro. And if you don't have the software licensed, it won't be on myesri.com, but you can go get it, an evaluation copy, through the normal evaluation channels. And lastly, it's been a pleasure talking to you today. On behalf of Esri, I'd like to thank you for watching this seminar. If you need to get in touch with me, there's my email address. So thank you and goodbye.